Hello everyone, you are welcome to today's tutorial. My name is Onya Adeleke. In this video, we'll demonstrate how to estimate the sample mean and calculate confidence intervals for population means when working with large samples in R. In today's class, we'll cover creating artificial data sets, calculating sample statistics, constructing confidence intervals using the normal distribution, visualizing our results, and interpreting what confidence interval really mean. Okay, so this is my R interface, and we are going to be starting by setting up our environment, as you can see, and we'll be generating an artificial data set. We will simulate height measurements from the population where the true mean height is 170 centimeters with a standard deviation of 10 centimeters. I'm going to be running line 1 to 8 now, and then I will be explaining afterwards. Okay, so the first line here, which is the set.seed123, is just to ensure our random results are reproducible. Is to ensure that our random results are reproducible. It means that if you try it again, you will get the same result because it's a random process. There's a tendency that it changes every time. And so the essence why I'm using set seed is so that when you try it and you're using the 1, 2, 3, you're going to get the same result as I am. If you're using another one, if you're using maybe 0, 0, 0 or 1, 2, 3, 4 or any other number, you have a different result. But if you continue to use that number, you will continue to have that same result. All right, so line 7 also shows that we are generating 200 observations. As you can see, that sample size is 200. Then the population standard deviation is 10. The population mean is 170. So with this information, we are asking R in line 8 to simulate 200 samples for us with this information, and that's what we have just done here. Now let's examine our sample data and calculate some basic descriptive. So I've run from line 11 to 14, and as we can see, our sample mean is 169.91, which is close to but not exactly equal to our population mean, which is 170. This is expected. Sample statistics are estimates, but not exact values. Then the next thing I'm going to be doing in my following line of code is to create a function that will calculate confidence interval for large samples. And for large samples, we use the Z distribution from the normal distribution. If it's a small sample, that means if our sample size is less than 30, we are going to be using a T distribution. So I'm going to be running my code now from line 16 down. Let's see. All right, so we've been able to create the function. Now I'll be explaining few of the components of the function so that we don't get ourselves confused. Okay, so we're starting from here. The function that we are creating is the calculate CI large sample. That will be the function name, and we are expected to input data and the confidence level whenever we are using this function. So we have the n here, which is the size, which is going to be the length of any data we are putting here. Then we have the sample mean, which will be the mean of any data we are putting. We have the sample standard deviation, which will be the standard deviation of any data we are putting here as well. Then we move to standard error. Standard error measures how much our sample mean varies from sample to sample. Then the Z value comes from the standard normal distribution. That's for 95% confidence, as I've stated here. And the Z value will be approximately 1.96. The next thing is the margin of error. The margin of error is the Z value that we've calculated times the standard error that we've calculated here. Then the confidence interval will be our sample mean plus or minus actually the margin of error. So when we are talking about the lower confidence interval, it will be sample mean minus the margin of error. When we're talking about the upper bound, the upper interval, we are going to be talking about sample mean plus the margin of error. Then we return the object as we can see. So that's the explanation of the function. Now, let's calculate and examine our 95% confidence interval. As we can see here, so the function we created calculates the I-large sample. I told us that we are going to need our sample data and we are going to need our confidence level. So we are going to need our data rather, and our data is the sample data that we've created here. So that will be the data we are going to be inputting. So when I run this, okay, then let me display my results. So 95% confidence interval, then the sample mean, as you can see. All right, so looking at this, we will see that our confidence interval is 168.61 and 171.22. Then you would notice that our population mean is actually in between this confidence interval as it should be. Actually, this is what we expect to happen about 95% of the time when we construct confidence interval this way. Then the next thing we are going to be looking at, as I have highlighted earlier, is to visualize what we have done. We are going to create a visualization to better understand our results. First, a histogram of our sample data with the confidence interval marked. So I'm going to run from line 52. Okay, so we can see the histogram right now. Let me try to zoom it. Okay, so we can see the histogram. Then I'm going to apply the mean line, then the confidence interval as well. So I will explain again. As you can see from the legend, you will see the red line, which is the sample mean. It's very close to 170. And that dotted green line, this is the true population mean, so they are almost overlapping. Then the blue dash lines are the confidence interval, the lower confidence interval and the upper bound, as you can see. Now let's compare confidence interval at different confidence level to see how they vary. So I'm going to be running from line 63 downwards. Okay, so we can see here that when it is 90%, when we're using 90% confidence interval, we have 168.82 and 171.01 as our lower bound and upper bound respectively. When we're using 95%, we have this. When we're using 99%, we have this. As well, let's visualize it so that we can understand the importance of what we are doing. Okay, so great. So notice that as we increase our confidence level from 90 to 99, the interval becomes wider. This trade-off makes intuitive sense. To be more confident that we've captured the true parameter, we need a wider interval. Finally, as we come to the end of the tutorial, we will demonstrate what 95% confidence really means by simulating multiple samples. I'm going to be running from line 85 down. So when we simulate 100 different samples and construct 95% confidence intervals for each, we expect about 95 of them to contain the true population mean. Our actual coverage rate read 94% and is very close to the expected coverage range, which is 95%. I hope we understand that. So quickly, let's do a recap of what we have learned. In this tutorial, we've understood that for large samples, we use the normal distribution to construct confidence interval. Number 2, the confidence interval gives us a range of plausible values for the population mean. Number 3, a 95% confidence level means that if we repeat our sample process many times, 95% of the intervals would contain the true population mean. Number 4, higher confidence levels produce wider intervals. Number 5, which is the last, the sample mean is our best point estimate, but the confidence interval quantifies our uncertainty. Remember, a confidence interval is not a probability statement about the parameter. It is about the long-run performance of our estimation procedure. So thank you very much for watching today's tutorial. We really hope you understand what we have taught so far, and we will encourage you to subscribe, to like, and to comment on this YouTube channel. Thank you. See you next class.